some of the things I had promised you. And what we'll be looking at today is one of the project goals that we have over here. So I will start the project skeleton, then I think from there, maybe you guys having the project skeleton, you can proceed on from there and perfect it. So let me start by introducing myself once more. So my name is Joseph Gitau, and I'm going to be taking you through these project diagram. So maybe one of the project statements that we have over here. So let me share my screen, then we can start. So I've been doing my research and I have something that we can use as our draft for this project. Okay, so I'm presenting my screen, and for what we are going to cover today is this part. So leveraging natural language processing and machine learning to create AI chatbot that can answer common health related questions and provide personalized recommendations to users. So let me copy this and paste it to an empty Google Doc. Then I think I'll share this with you once I'm done. So healthcare chatbot. So this is what we are going to look at. So let me make that a heading. So when dealing with such kind of topics, so where I'm saying like we are going to leverage natural language processing and machine learning to create an AI chatbot that can answer common health-related questions and provide personalized recommendations to users. So the first thing we need to consider is the tool we are going to use. And in this case, for me, I chose the Rasa chatbots. So these are bots that can be used to communicate with users. So if you want to learn something about the Rasa chatbots, you just have to search for that, then open their documentation website. So this is what they have. So I'm going to take you through the workflow of how we can connect our Rasa chatbot and how we are going to like integrate it to our project. So we'll head over to resources, then let's check the open source, some of the open source projects that are there. So you can see it's build ML powered conversational AI. So these models, these bots will be powered by AI, and we will be using NLP. So Rasa uses NLP to do this. So you can check here for the open source stuff and all that. So what I'm going to do is I'm going to head over to the Rasa documentation. And this is the website, so the developer documentation portal. So from here, we'll be able to understand like how we can create our own bot from the start and how we can use it. So we'll start by this part over here, which is install the Rasa open source. Okay, so this is Python setup. So for me, I usually use Visual Studio Code. So I will open my VS Code. Then I have to reset this view so that you can be able to see my code. Okay, so I think everything should be okay now. So over here on my desktop, let me create a new folder. So for this folder, it should be the Afric CDSA. Then I'll open this folder. Then over here, I'm going to create my Rasa board folder. Then I'm going to open these using Visual Studio Code. Then we'll begin the installation process for Rasa so that we can come up with our own sample board. Okay, so this means, so I'll open my terminal. So terminal, new terminal. Then I will head over back to our website over here. So first of all, we need to set up our Python environment. So let's check our version for Python. So let me check my Python version. So I have Python 3.11 installed, and also I'll check my pip3 version. So I have pip 22.3.1 installed. So I think the versions have no issues as long as everything is running. So we can see what they have over here. So Python 3 supports versions. So currently Rasa supports the following versions of Python. So 3.7, 3.8, 3.9, and 3.10. So note that Python 3.10 is not currently supported for Rasa installations on Apple Silicon. So if you are using an Apple Silicon device, so this will not work. Okay, so next, we need to install some packages, so like update some packages. So we have pip, so we won't install that. Next, we need to set up our virtual environment. And why are we setting up our virtual environment? It's because in this environment, we will be just using the packages we need for the Rasa board. So we won't like have to install everything in our environment, in our main environment. So I'll copy this code, then paste it here. Okay, so I have to delete some things here. So we have type in Python 3. Then over here, I have to give my environment a name. So I think I'll change this to Rasa. Instead of venv, I'll have it as Rasa. Then next, after that, we need to activate our virtual environment. So let's wait for this to run, then we'll proceed. Okay, so I have my virtual environment created, so let me activate it. Okay, so I have my virtual environment activated. So you can see over here on my terminal, I have Rasa now active. So it means that this virtual environment is what I'm using. I'm not using my normal Python installation. So I'm using that virtual environment. Okay, so let's scroll down. So the next step will be the installation of the Rasa open source board. Okay, so we have our pip installed. So next we have to copy this. So pip install Rasa. So I don't know how long this will take. So hope my internet connection is fast, so that these won't take long. Okay, so as that is running, I need to show you some of the other research things we need to do. So after deciding the tools that we are going to be using, so we need to also decide which prompts our bot will be covering. So prompts, and for the prompts that our bot will be covering is like asking questions like, how are you feeling? So let me have this in list form. So we'll have user current condition. Then we have user symptoms. What else do we need to know? If user is under any medication. So I think we can start with the first three. So these are the prompts we will require to like get from our users. And I think from here we can come up, so from the prompts we can come up with the feedback. And from the feedback is, so from the feedback we have the normal ones, so things like greetings. So if someone greets you, you have to like reply with that greeting. And if someone replies with these symptoms, then we can reply with our diagnosis. And for this diagnosis, we will create a sample disease, maybe, for example. So we have to like research a little bit on this, so see how we can diagnose this patient. And I think data is online. So for example, if we were to search for things like symptoms for malaria, this is what we get. Yep. So you can see we have the severity graph, so things like that. So we can leverage NLP to like get this data, yeah, and come up with a diagnosis ML model whereby a user can input his symptoms and we can be able to like predict what kind of disease this person is suffering from depending on the symptoms we are being given over here. And also we can use things like the location of the user, since I think, so let's check this. Okay, so maybe for location we can get it as an input from the user. So with all these symptoms we can fit like a machine learning model to get these symptoms and try and predict what a user is suffering from. Yeah. So this is the kind of data we will need. So symptoms, diagnosis. And for the diagnosis, you can see if we leverage what is here on Microsoft Bing, we can extract the symptoms and the diagnosis. So someone can do the scraping for this. And I showed you how we can do this. So for example, if I want to scrape the data for malaria, what I will do is I will come here, open my instant data scraper. Then over here you can see I have my data selected, right? So there are other tools we can use to scrape this data, but I think this will work best. So once I scrape that, I can save it in a CSV file or any other file. Then I will, so for example, over here we have the common symptoms. So I will try structure this data in a neat way. So that's why in this document that I shared over here, we have the data collection and the data cleaning. So when I'm scraping this data, you can see it's not structured in a way that I can understand. Like I can understand it well at first. So I have to like structure it in a way that I can be able to like feed it to a machine learning model. So let's ignore that first, since our main focus today will be on this. So the Rasa bot first. So it's still installing. So as it is still installing, we'll try explore some of the things we are looking at. So once we've scraped this data, so we will scrape the symptoms, diagnosis, and maybe suggest some of the treatments. But ours will be just like a suggestion. So you see the suggestions that we have over here. So it will be similar to this, since we don't want to like give patients go ahead as to the kind of treatment they should seek, since we want them to like consult with real doctors and also go for laboratory tests. And from these laboratory tests, we can maybe have the users of our interfaces come back and confirm if our model was right, if our model did predict correct what they were suffering from. So things like that. So my Rasabot is still installing. I think I can switch my internet connection to a more faster one. So just give me a minute. This part. So you can just proceed on from where we were. Okay, so this should be a little bit better. So as this is downloading, so I think we can scrape data for two symptoms that we have over here. So for two diseases, so I'll have malaria, which is more common. So let me get that data. So for that, I'll have to delete that. So I'm deleting some of the unnecessary things that we are getting from this website. Okay, so let me save this as a CSV file, open it on Excel, then we can do some data cleaning. Okay, so as you have learned, maybe from some of you who have enrolled to our courses, so the data cleaning part is the data cleaning and the data pre-processing part takes quite a lot of time as compared to the model fitting and all that other stuff. So this is the data cleaning part. So I need to remove things that are unnecessary for us. So I think that's unnecessary, that's unnecessary, that's unnecessary. The title column is also unnecessary, we don't need that. Okay, so for this column where we have dates, unnecessary, image. Okay, so let me check this. Okay, so these are also unnecessary. Or what we can do is, instead of scraping this data here directly from the websites, we can go ahead and search for this data. So disease and symptoms dataset. So I think we have one from Kaggle. I think that should be reliable. Or we can use this dataset here from Data World. So that's still installing. Let me close. Hello, sorry I closed my browser. So I was trying to close the data scraper, but I forgot and did close my browser. So let me share my screen again. Then we can proceed on from what I was showing you. Okay, so as you can see, we are still installing our, okay, so our board is still installing. So we have around 438 MBs installing. That's quite large. So I think I can skip this part, then we can have another session whereby, okay, so anyone with a question?
Yes, Mr. Joseph. How the evening? Yes,
Yes.
I've joined the letter. Yeah, I've joined the letter. Can you please, maybe after the
Yes.
lesson, can you repeat on how to install the process, the installation process?
So the installation process for this Rasabot.
Yes.
Okay, so I think I'll try and share. Okay, so Sevia is recording this session, so I think you'll get to see what I was doing. Okay, thank you, Sevia, for that. Okay, so we were looking at the kind of data we wanted. So over here we have some healthcare data, but I think this is not really what we needed. So I think I'll go for the Kaggle dataset since we have the diseases and their symptoms. And from the diseases that we have over here and their symptoms, so okay, so let's see if we can get this data set. So we have the Parkinson disease data set, diabetes data set, not really what we want. So let's look for these data. Let's look at this data at Stack Exchange, and we can also look at this data on GitHub. Okay, so I'm trying to source some data over here and see if we are going to get the kind of data we need. Let me download this first, then we can see if it's the kind of data we need. So remember, like when you are handling such kind of projects, it in some instances you will find that someone else has already done what you want to do. But what makes your project unique is what you do with it, like what kind of features you include in your project. Okay, so let's have a look at the dataset.csv file that we have over here and see if it's the kind of data we need. So this is still installing. Yep, so this is the kind of data we need. So you can see we have a fungal infection, symptom 1, symptom 2, symptom 3, symptom 4. So, and we can list all the symptoms we need, so up to symptom number 17. Okay, so how many kind of diseases do we have here? So we have malaria. These are the symptoms for malaria. We have typhoid, hepatitis A, hepatitis B, hepatitis C. Okay, so once we have this kind of data, right, what you need to do next is try process this data. So for those who take my machine learning course, I've been teaching you a few things on machine learning, and one of the thing is if you are dealing with data that is if you are dealing with data that is in text form, you have to convert it to a numeric form for you to like fit a machine learning model to this data. Okay, so what we can do here is concatenate all these symptoms into like one thing, right? So for example, if it's itching, skin rash, nodal skin eruptions, these chromic patches, we can like combine them to one. And how can we do that? So first of all, we have to like combine all these into one vector kind of thing. So let me open my VS Code, and as this is running, show you how we do this. So in this Rasabot folder, so I'm going to create a new file. So I'm going to name this file as my analysis.ipyn. So this is a Jupyter notebook. Then I'm going to, so this file that we have over here, I'm going to copy that file and I will paste it to that folder that I'm working on. Okay, so let's start our analysis. So first of all, we have to like import some basic libraries. So basic Python libraries that we are going to use. So we are going to have import pandas as pd, then import numpy as np, import Simon as sns, so things like that. Then next I'm going to read in my data. And to read in my data, I'm going to have our df should be equals to pd.read underscore csv. Then here we are going to have dataset.csv. So what we have over here, then I can run this. So let's see. I think I have to choose environment. So I'll use my base for this, since this is just for analysis and I need access to my machine learning libraries. Okay, so that is running. Let's give it a few minutes. Then you can have df.head. Okay, so PD is not defined. Let's run that first. df.head here. Then another thing you need to note is if we run df.is na.sum, you'll notice that for some columns we have data missing. So this is quite okay. So it's not something bad, since we know that, for example, for the diseases that are over here, so some have more than 17 symptoms and some have less than even 4 symptoms. So yep, we need to ignore the missing values in these kind of instances. So once we have our data like this, right? So we need to kind of see, for example, for symptom 2, what is the most common symptom in that case? Or for example, symptom 1, what is the most common symptom there? So we'll have, so what can we use? So we can use symbol. So we can have sns.countplot. Then we can have our x being equal to symptom. So it should be symptom underscore 1. Then our data should be equals to df. So let's run this, see what's the most common symptom. Okay, so symptom 1, so I think it should be capital S. So for that, let's see what we get. So it's, the list is quite large. So what we can do is we can use a value count. So we'll have df dot, so df then symptom 1. Then we can have dot value counts. Then we can run this. So you can see, for example, the most common symptom is vomiting. So for symptom 1, the second one is fatigue, itching, skin rash, chills, joint pain, continuous sneezing, headache. So over here, let's take the top 5. Okay, so I don't know if it will use dot head or something else. So dot head works. Yeah. So the most common ones is vomiting, fatigue, itching, and skin rash. So let's check symptom 2 and see if we'll have similar things. So we have, yep, so we have similar features. But over here we have another common symptom, which is yellowish skin. And lastly, we can check symptom 3 and see if we are going to get similar things. So you can see, as we are going through, exploring through the symptoms, we are kind of getting new symptoms on each column. So as I had mentioned earlier, I informed you that for machine learning models, we can't really work with these symptoms as they are. So we need to like encode them, right? So what we'll do is we'll use NLP, right, to convert the text to numbers. And and then use the numbers to train the model. So let's import the NLP libraries that we are going to use. So we are going to have from sklearn dot feature extraction dot text import count vectorizer. Then I think we also have to import TF-IDF transformer. Okay. So after that, we need to create the bag of words model. So the bag of words model is something that carries all these words in terms of the numbers and all that. So we are going to have our bag of words being equal to, okay, so just a minute. So since this is somehow new to some of you, let me show you how you can research this process. So what you need to do is go to your website and search for NLP feature, let's say NLP feature engineering. So once you have that, you can open any of the tutorials that you have over here. So I'm going to open the first link that we have over here, and you will be able to see like the steps that are followed in doing the feature extraction process. Okay, so let's search these. Okay, so over here we have an article showing you all the steps you need to follow to do that. And in NLP we have step number 1, which is count the number of characters, count the number of words, the number of capital letters. So first of all, in our data set, we need to lowercase everything that we have over here. Yep. So that's already done. Count the number of punctuation marks. So in our data, we don't have any punctuation marks, so we don't have to like worry about that. Then number of words in quotes. I believe in this data we don't have any words in quotes. Then number of sentences. Yep. So we can do that. Number of unique words. Count of hashtags. We don't have hashtags. So things like that. And we don't have the stop words or things like that. And I think these are the formulas that have been created, but in our case, I believe we won't be using this much. So we will be using this part, which is the encoding the text parts. So we will be using the TF-IDF and so we've imported TF-IDF vectorizer and all that. So we will be using that to convert our data into numeric features. So yeah, so just give me a minute, then I'll show you that process of doing that. And we'll do that for column 1 only, or just a sample of column 1. So what I'll do is I will do this. So we'll have df underscore sample should be equal to df dot sample. Then we are going to take the first 40 samples. So df underscore sample. So let's see what we have in our sample set. So in our sample set we have 40 samples. Okay. Right. So once we have that, let me share the process for doing this. So I'll start by showing you a sample. So let me remove this first. Okay. So actually the IDF transformer, we don't need it. So we'll have some sample underscore text. So for the sample text, we'll have something like this is an Afric CDSA open source project. And after doing that, we will have our vectorizer being equal to count vectorizer. So which is our model. So after doing that, we need to like fit that count vectorizer to the text. So we'll have vectorizer dot fit, then we'll have sample text. Then sample text dot split means we are going to like convert it into a list, right? So we need to like convert it into a list, but yeah, I think that's a must. So you must convert this into a list. So maybe we can have this something like this. So that's our first sentence. And for our second sentence, we'll have this is an Afric CDSA open. So I will delete the word open source and we'll have open project. Then I will remove this dot split part since we don't need it at the moment, since already our data is in terms of a list. Then next we need to transform it since we have fitted it to our model. So transform. So this is just like preprocessing. So we'll have our X, so which will be our new data being equal to vectorizer dot transform. Then we'll have transform the sample text. Then after that, we need to maybe print our output. So we will have print the output or the vectorized text. So we'll have print x dot to array. So we need to convert our output to an array so that we can be able to see like what we are getting. So let's run that and see. So you can see this is what we are getting. So this is an Afric CDSA open source project. So for that first list, we are getting only ones. Yeah. And for the second text that we are having over here, we are having it being encoded by ones and zeros. But for this part, which I deleted the name source here, you can see we have a zero since this text source is missing here. So this same thing will happen to the same thing that has happened to this sample text that we are having over here will also happen to these text symptoms that we are having over here. In that, if we have fatigue over here, or maybe for example in index 4605 we have vomiting, and in index 4351 we have vomiting. So it will mean that in these cases where we are having vomiting, we will simply have a list with the same array output. So for example, if it was an output of 111, we will have the 111s again. If it was 11101, we will still have that. And the last thing I think we can print is, so I think we can print the corresponding feature names. So we have print vectorizer.get feature names. So let's run this and see what we are getting. So yep, these, so we have a warning over here. So let's ignore warnings. So we'll ignore all warnings. So these are the corresponding feature names. So for example, you can see Afrix CDSA has been encoded with a 1, and has been encoded with a 1, is 1, open 1, project source. So each letter that we have over here is being encoded with a number, and that number is all on a random part. So for example, if I was to change this text or add a third text and say like my name is Joseph, and feed this model again. So let's run this, see what we get. So you can see like our vector now has changed, right? So we have 111,000 and that. So you can see like it's just like creating a DNA strand, whereby each DNA has its own unique identifier. So each sentence that we have over here has its own unique identifier. And that will be the case for each and every symptom that we will be having over here. So each symptom that we are having will have its own unique number. So for example, if I was to extract these, right? So maybe copy that number and say reverse vectorize text, so something like that. So we can use inverse transform X, and you can see what we get. So the inverse transformed X will give you that. So this is the first list for the inverse transformed X. This is the second list for that, and this is the third list. And in our case, we have an advantage. Do you know why? Since we are using, we have an advantage since we are using single words. So for single words, we will only be having like single numbers for that. Yeah. So I think we had an error over here. Okay, so this is invalid. So I'll try install this again and see if it will work. Okay, let me see how I can debug this error. And I guess it's not a must we install TensorFlow, since we won't be using TensorFlow for this. Okay, so let me cancel this. But before I cancel, let me just leave it. Since we still have some few new libraries being installed. So yeah, let me cancel it at that part since we don't need TensorFlow. So I'll open my terminal, then activate my Rasa environment. Then we'll go back to the Rasa documentation website. So once Rasa has been fully installed, so you don't have to like install TensorFlow. So let's run Rasa in it and see if it has been installed. So not yet. So I'll have to figure out a way of bypassing the TensorFlow part for you guys, and I'll share that tutorial with you. So maybe the next time we are meeting, I'll show you how we can do that. Or maybe I can pre-record a session for you guys to like see how I install the Rasa board from the initial environment creation till the end. Okay, so over here I was showing you this, how we convert the sample text to numeric value. So what we'll do next is now fit the model. We'll now fit the model to so to column 1 of our sample DF, our sample data. So we will have our we will have the fit vector. So we'll have vector.fit, then we'll have df sample, then symptom 1. So symptom 1 is our symptom 1 column over here. Then after fitting that, you see the next thing we need to do is the transformation. So we will have transform. So we'll have our x being equals to df1 dot transform of all of that. Then the last step is print the vectorized text. So print the vectorized text. So let's print this and see if it works. So you can see for our data frame now, so for our sample data, we now have our features now transformed. So with these features transformed and in vector form, we can now go ahead and fit machine learning models, whereby, for example, if we had these number that we have over here, it will represent a unique symptom that is in this data set. And basically that's what we will be using to like create our healthcare assistant system. So I think I will stop there for today as for me. So I'll share this notebook with you guys, and I'll also share the data set with you so that you can explore what I've shown you now, and also try research more on your own as to how you can come up with even better ways of solving this problem. So before maybe we end the class, I will wish to like answer a few of your questions. So let me check the chat. Okay, so we don't have any questions. So anyone with a question he or she needs to ask. Yes, Yusuf.
I'm about to know the installation process.
Okay, so for the installation process, as I have mentioned, I will share that afresh from the start till the end. Yeah. So I will re-record that and share with you guys since I had an error over here while installing that Rasa package.
Okay.
Yep. Any other question? Okay, so if we have no other questions, I think we can end the session there for today. So I will share some few notebooks and some few tutorials on what we've covered today. Then I think we can proceed on from